Hi, everyone, and welcome to lesson 19.1, which is on page 247 in your Springboard books. Today, we are going to start investigating the inverse of our trigonometric functions. So, on page 247, you see this lovely picture of a telescope, and the telescope swivels across here to be able to look from east to west at the sky. So if we look here through this information, it says that this telescope is 200 inches long. So this 200 then is associated basically with kind of the hypotenuse of this right triangle that's drawn in. And the distance that we have here is kind of our adjacent side, right? We have the 200 inches as kind of the hypotenuse and the adjacent side. So we're kind of dealing here with a limited graph than what we would normally see. If we're just looking at this east to west portion, we see that we're kind of limiting this to be between 0 degrees and 180 degrees, or 0 to pi radians, but we'll go with degrees for now. And we see like this input value here is another way of representing that. And again, we're going to want to use cosine because we're looking for this distance here, which is the adjacent to our theta. We have the hypotenuse, so the cosine, again, adjacent over hypotenuse. So cosine of theta is adjacent over hypotenuse, d over 200. And again, we're able to use cosine right now because this is a right triangle drawn in here, right? That's how we know separate can be used. So in order to, if we look on the next page, then find these given values, if we were looking at different values of theta, we could start actually calculating these values. So cosine of 60, if that's our theta, equals d over 200. We can figure out that distance, in this case, by multiplying both sides by 200 so that we can find that distance. Now, a couple things to note. Make sure, as always, very important that our mode is constantly being looked at here. Since we're dealing with degrees, we want this in degree mode, so make sure your calculator is there. And then, again, 200 times our cosine of 60, which is 1/2, should be 100, right? So 100 inches. And if we test out the next one, you should have gotten that our other angle, if we type in 110, all we can do is approximate this as best as possible, but it would actually be the exact same set out. We're just changing the 60 to 110. It's actually going to give you a negative value, which makes sense that this is negative, because if we go back to looking at the diagram, if we're in this negative portion over here, we're over on this part of the axis, right? So even though it doesn't really make sense that it's a negative amount of inches, it's in the second quadrant, and we know cosine is negative in the second quadrant traditionally. So it's kind of showing us that it's making it a westward facing ray versus if it was 68 in the positive direction, it would be eastward facing our direction of our telescope. Okay. Now from here, we know that there are some values around the unit circle that give us these values, right? So if we think about, around the unit circle, if we're at pi over 4, if we're in radians now, we know we're at the square root of 2 over 2, which is going to be about approximately 0.707 meters. 2 pi over 3, cosine of that is negative 1/2. Negative 0.5, and then pi over 2, kind of the top point of ours, is going to actually give us a cosine value of 0 meters because, again, we are right on there. So, again, going back to our unit circle in radians, looking for the value of d, or, again, we're going back to cosine right now around each of these values. Now, shifting gears, we want to think about domain and range and what makes something a function, right? What makes something a function? Well, functions we know are one-to-one. For every input value, there's only one output value, passes that vertical line test, right? So when we look at something, we have to be careful because traditionally, if we graph cosine, right, we know that if we have like a traditional cosine graph that we've been talking about now for what seems like probably forever, we know we have something that looks like this. And and currently it's passing the vertical line test, right? Cosine is a function. But what happens if we keep repeating our cosine graph, going on and on and on, and we want to talk about the inverse, right? What has to happen to make the inverse also be a function here? Because currently this won't happen because it's not passing the horizontal line test, right? The inverse would not be a function. So on this next part, as we're working through, we want to think about the things that would have to happen in this and to make not only this graph a function, but its inverse a function. Because if we graphed what we just went over, right, in radians from 0 to pi or 0 to 180 degrees, again, we're starting at 1, and then we have those approximated values from those values around the unit circle, like 0.707 and 0.866, all that. As we move around, we have this graph, right, this piece of our cosine graph, 1/2 of it. The problem is if we keep extending this graph on, it would still be a function, but its inverse would not be a function. So we're only going to look at this piece here. And the domain and the range, again, this is just a graph of cosine or part of it, is between 0 and pi, which is going to be its range on this graph. And then domain, and then the range is going to be from -1 to 1, right? If we look at this graph, again, it does pass the vertical line test because it is 1 to 1, right? However, if we would extend it out, it wouldn't be. So it's important to keep our graph as is because it will pass the horizontal line test as is. If we extended this on like it normally looks, it would not. So that's why we have this limitation on our cosine graph currently from just half of it to just see that point. And we see that down here. Is this inverse right now going to be, is the inverse going to be a relation here? And the answer is yes, because it passes the horizontal line test. So that may be something you want to note. This passes the vertical line test, so that's why it's a function. The inverse is also going to work because it passes the horizontal line test. Okay. And again, it would not be able to do that, however, because if we didn't limit that, then the cosine graph would not be 1 to 1, right? It would not be 1 to 1, and we wouldn't pass, right? So that's where those are going. Now, again, we have some vocab here talking about these inverse trig functions then. So as we look here, on the top of the next page on 250, it talks about 1 being 1 to 1 and an inverse trig function existing. So notice the way this is being written here with the little -1. This is not saying, cosine of the negative first power. This is going to be talking about calculating the inverse. And basically what the inverse allows us to do, and this is the chart you see at the bottom of page 249, is it flip-flops things around, just as inverses have done with logs versus exponentials. We have cosine and then cosine inverse to look at. So essentially what happens is if we look at our normal, going around the circle and looking at these exact values on our graph of what, each of these represent all the way to 1 pi, in our inverse, what would happen for cosine inverse, these would switch. These are now your input values, your output values are now this. So it's almost like looking at the unit circle, and instead of saying, at 60 degrees, it's this value, you're now looking at, it's this value, it has to be 60 degrees, right? That's kind of what we're looking at here. So on the top of page 250, again, you should see all that vocab we just talked about. And then it also has, can we use this table to obtain these values? And the answer again is yes, because we can flip-flop them around, which also means that our domain and range are going to flip-flop around, because our domain previously of cosine of x, we said the domain was from 0 to pi, right? And the range was -1 to 1. Well, now that's going to flip-flop, right? The domain now for cosine inverse is the range of cosine. It's going to be -1 to 1 for the x values, as to where our range is we're only going to pick values between 0 and pi. And this is what your calculator is going to only give you answers between 0 and pi, is because of this reasoning and limiting it to be in that particular range, okay? Now, this function then of the inverse would look like so, because again, we're only using now the y values from the old graph are now our x values, and our x values from the previous graph are now our y values, and this is our flipped around. We're just basically taking that table from the previous page and flipping them around. Okay, and some information, we have some zeros occurring at x equals 1 over here. The function is never increasing; it's always decreasing as we move down this. We're constantly moving down from left to right, and it's decreasing always over this entire interval from -1 to 1 that we see here. Okay, so again, some important things to note about our cosine inverse graph. That on here is, the domain and the range, that it's limited in your calculator to quadrants 1 and quadrants 2. Okay, now eventually we will talk about solving it over quadrants 3 and 4 all the way from 0 to 2 pi, but you need to understand your calculator will always only give you an answer for quadrant 1 or quadrant 2, and then it'll be up to you to use your information about where quadrants are positive versus negative. But it goes back to making this function exist is why your calculator will limit things. Okay. And then just to practice a little bit in these examples, again, why are we restricting it? I feel like we're kind of beating it over here, but we have to make sure that we restrict it so that things stay 1 to 1. Otherwise, it would not pass that horizontal line test to make the inverse a function if we don't restrict cosine itself. And then when they're actually asking you for the cosine inverse to calculate it, again, you want to think about your unit circle. Where in quadrants 1 or 2 is my cosine value equal to +1/2? Well, cosine is negative in quadrant 2, positive in quadrant 1. So we know it's a quadrant 1 value since it's positive, and it's equal to 1/2 at pi over 3 radians, or 60 degrees if they were asking for degrees, right? For cosine of -1/2, again, that's in quadrant 2 because it's negative, and that occurs at 2 pi over 3, that the cosine is negative 1/2 on our unit circle, or 120 degrees. Okay. Now, you'll also see cosine inverse, sometimes stated with cosine inverse. Another way you'll see this stated, it's equivalent to calling something the arc cosine, just as a note. And you are able to calculate this in your calculator. So for instance, if we were looking at this last one, cosine inverse, second cosine gives you cosine inverse. This is not for secant. All right, they are completely different things. Cosine inverse, and then of 1/2 or 0.5 was the 60 degrees versus cosine inverse of -1/2, which we said was 120 degrees. Okay, so you can check that in there. And again, it goes back to, instead of finding the side length, you're now finding the angle measure, which relates back to our geometry days, that this means that you are finding the theta versus the side length, right, which is what we were doing before. Okay. All right. Thanks, everyone, and we'll definitely be working more with this over the next few days.